Another great named reaction is the Gabriel synthesis. This is a reaction I've run in real life. It's honestly not too bad. So this is the Gabriel synthesis, and it's used to make primary amines here. You can see it is a two-step synthesis, and I will say this synthesis is something that looks way easier on paper than it is in real life because there's a lot of long refluxing and a lot of multiple washes and extractions for this in real life. But on paper, it's simply just two steps. And the first step is we take our potassium phthalimide. Now you can purchase this readily, or you can make it on your own, taking phthalimide and potassium hydroxide. They'll make potassium phthalimide. Now we take some sort of alkyl halide, where the R group is what we want to attach to our amine. Remember, this only makes primary amines, okay? In the second step, we finish it off with some hydrazine to kick off our alkyl group from our phthalimide, giving us our primary amide. So how does that happen? This is, again, using simple SN2 chemistry you learned in Organic Chemistry 1. So this nitrogen is negatively charged. It's going to come and attack our R group. We're going to kick off our halide group. It's going to make some sort of potassium halide salt. And what we're going to get, try to draw slightly smaller so we can keep this on screen, is I called it an alkyl phthalimide. I don't know if that's the actual IUPAC name, but oh well. Where you have your alkyl group now bound to your nitrogen. Then we have hydrazine for our next step. So what happens is hydrazine looks like this, by the way. Two NH2s bound to each other. So what's going to happen is one of these is going to nucleophilically attack the carbonyl carbon of our imide here. So it's going to attack like this. We're going to get a structure here. We're going to crack this open a little bit, where we have our oh, I just realized I forgot the double bonds in there. And we're going to have to push these electrons up as well. I'm sorry. So we're going to create a tetrahedral intermediate. We have O minus. We have our nitrogen, and this is now bound to our NH2 plus and NH2 and our carbonyl. Now, what happens is these flow back down, and we're going to kick this off. And then there's kind of a hand-wavy proton transfer step in there. Oh, I forgot the double bonds here too. And we get this. If you want, you can explicitly draw the proton transfer step. So what this is would kick this off. This would make this a negative charge. It's going to just steal the proton from this positive nitrogen. You know, bada bing, bada boom. So we have this up here. NH, NH2. And what's going to happen is we are just going to attack that carbonyl again. Oh, forgot our. We're going to attack this carbonyl again with this one here. And we're going to do the same steps where we push this up, and then we're going to collapse it back down. And let's see if we can fit this all in here. Oh my goodness, I keep forgetting our double bonds. That's a terrible end. Minus. I still won't like that N. Where these electrons are going to flow back down. We kick this off. Proton transfer step, and we get our primary amine as our final product. Like I said, I've run this in real life. Based off my experience and that of my friends, realistic expectation of these is probably about a 30% yield over 2 steps for your primary amine. Again, that changes based off what this R group is for you. But remember, for class, your yields don't really matter in lecture. So just remember, we have a potassium phthalimide. Maybe you buy it, maybe you have to make it your own. And then we nucleophilically attack an alkyl halide, simple SN2 chemistry. And we create this alkyl phthalimide, as I like to say. We have hydrazine, and where the hydrazine attacks the carbonyl. It happens twice. And we finally get our alkylamine, our primary amine. And what you end up making as a side product is this right here. I think it's called phthalhydrazide. I think. Don't quote me on that. If someone knows, let me know in the comments. Where you have NH. Comes a 6-membered ring there instead of a 5. That's your side product. So if you want more organic chemistry learning, be sure to hit that follow button.